Hello everyone, welcome to the 8085 programming series. Today we'll be doing this particular program. So we have 10 bytes of data which are stored in memory location starting from 8040. So write a program to transfer the data bytes to memory location starting from 8050. So we have 10 bytes starting from 8040. Then after 804 we have 4142 up to 49. We have 10 bytes of data stored in each memory location. So we have to transfer the data bytes to memory location starting from 8050 to 8059 in such a way that whatever is in 8040 it gets stored to 8050, from 8041 to 8051 and so on up to 8049 to 8059. So this is the program. Okay, so you can see these are the instructions, mnemonics. So the first instruction is LXI H8040. So this instruction will actually initialize the source memory pointer. One more, and then this instruction LXID, it will initialize the destination memory pointer. Okay, so we will use a loop instruction so that whatever we have to transfer the data bytes, and same sets of instructions will be required. So instead of writing them 10 times, we will write just once and run a loop 10 times. So this is the source memory pointer, this is the destination memory pointer, and MVIC 0A. So we need to load a counter because we have to run these instructions 10 times because there are 10 bytes. So this is 0A. Now we must take care that 10 is in decimal, but the data which is accepted by this microprocessor 8085 is hexadecimal. So we need to convert this 10 into hexadecimal, which is 0A. So if instead of 0, if we write 10, okay, then it will take 16 bytes of data. So this is 0A. Next instruction is move A, M. Now because of this move A, M, whatever data is in 8040 memory location, it gets stored in register A. And with STAXD, the data which is in register A, it gets stored to memory location which is pointed by DE register pair, which is 8050. Then we have INXH. Now INXH, it ensures that this 8040 becomes 8041, and INXD, it ensures that this 8050 becomes 8051, and DCRC will decrement this particular counter, so 0A becomes 09, and immediately after this we give the instruction JNZ, that is jump if no 0 to 8008. So if this counter is not 0, it will go to the next, okay, instruction 8008. And because now this M is the memory pointer pointed by HL and it has become 8041, so the data of 8041 will go into A. So what we are doing here, we are transferring the data of this memory location to A and from A to 8050. So in the actual program, what we will do is we will take some data in a register. So we have in the memory location. So what we are going to see is okay, I'll just explain the flow. Okay, so we need to store some data before writing the program. Okay, so I have stored this at 8040. Let us assume that there is 10 at 41, there is 20, 30 and so on. Only 5 memory locations are shown. So this 10 after execution must come here, and this 20 must come here. So I will just show one or two instructions, one data byte transfer. So with LXI H8040, this H and L, the H contains 80, L contains 40, and they also act as a memory pointer M. Okay, and with LXID 8050, 80 gets stored in D, 50 in E, and we can also use them as the memory pointer. Okay, DE. Now with MVI say 0A, 0A gets stored in register C. Now with this instruction move A, M, the data in memory location which is pointed by HL, that is 10, it gets stored in register A. So A gets 10. With STAXD, the data from register A, so STX means store accurate indirect, so data from register A, it gets stored in memory location pointed by D. Okay, so we cannot transfer direct memory to memory, but we can use a register. Now we are using register A. Then with INXH, what it does is it increments this pointer. Okay, so it becomes from 8040 it goes to 8041. Okay, so this transfer is done. So we need to move to the next memory location, and then with INXD, this D pointer shifts ahead and with DCRC the counter 0A step, just click on this memory, okay, and then you can store directly to the specified memory location. We'll just click here, and then we can just type here 8040 because we have to store some data. So we'll just type 80440. So I have to store the data 10 here. I can store any data, but because we must know what will be transferred, okay, then next is 8041. Okay, so we'll just go on typing the data here. Okay, I'll just do it quickly. Okay. So I have typed the, all the memory locations, the data in the memory location. So 8040 contains 1041 contains 20, and so up to 8049 it contains A0. Now let us run the program. Okay, so let us first run the program checking the register contents. So I'll just take the step mode. Okay, so with the first instruction LXH 8040, as you can see 80H contains 80, L contains 40. With the next instruction LXID we have 8050. So LXID, so 80 gets stored in D and 50 in E. With the next instruction 0A gets stored in register C, as we can see here, and then move A so if you remember, in the very first memory location which was pointed by 8040, it contains 10. So you can see 10 gets stored in register A. Okay, and then with STEXD, the data from A, it will get stored to 8050. Let us check it. So I'll just click here on memory location, and as you can see, this 8050 has been created and 10 is stored in this particular memory location. Okay, so this is the one advantage of this simulator, that we can just go stepwise and check the contents also. Now with INXD, INXH, what we'll see here is this 8040, which was in H, it becomes 8041. You can see 8041, and with the next instruction INXD, it becomes 805. The D becomes 8051, and DCRC, with DCRC, C becomes 9. Okay, and then J and Z up. Okay, now because the carry flag, zero flag is not set. Okay, you can see zero flag, this is not set, so it will jump up. Okay, it jumps up. With this instruction, the next data, which is 20, okay, you can see this is 20, at 80, this is 20, this 20 gets stored in register A. Okay, and this will continue, okay, until all the data bytes have been stored when the counter becomes 0. Now this is okay, we'll just go on running this until C becomes 0. Okay, when C becomes 0, it stops executing. You can see it is halt, and let us check the memory data. As you can see, A50 contains 10, 51 contains 20, and so on, 20, 30, 40 up to A0. So this is how the program works. So that's all for this particular session. Thanks for watching.